Imagine you find a magical bank that offers a wildly generous interest rate, 100% per year. If you put your $1 in, wait exactly 1 year, the bank hands you another $1. You now have $2. Mathematically, this is 1 times 1 plus 1 equals 2. But you are a clever investor. You ask the banker, instead of giving me 100% at the end of the year, what if you give me 50% after 6 months and another 50% at the end of the year? Why do this? Because during the second half of the year, that first 50 cents also earns 50% interest. Your final amount is now 1 times 1 plus 0.5 times 1 plus 0.5, which is 1 plus a half squared, equals 2.25. You just made an extra 25 cents by simply chopping up the wait time, so you get greedier. What if you give me 1/12 of the interest every month? Now you have 1 plus 1 over 12 to the 12th power, which is approximately 2.61. What about every day, every hour, every second? You might expect that chopping time infinitely fine would make you infinitely rich, but look at the graph. As the timeline updates infinitely fast, the curve doesn't shoot to infinity. It bends over, it hits an invisible ceiling, a mathematical speed limit. That ceiling is exactly 2.71828. This is the birth of E. It is the maximum possible yield when 1 unit grows at 100% over 1 unit of time, compounding continuously. The limit as n approaches infinity of 1 plus 1 over n to the power of n equals E. Let's step away from money. What does continuous compounding actually mean in the physical world? In the bank, growth happens in discrete ticks, like a month or a day. But nature doesn't use clocks. Nature grows continuously. Imagine a population of bacteria. A single bacterium doesn't wait exactly 1 day, sound an alarm, and then split into 2. It is constantly absorbing nutrients, constantly growing. And as soon as new bacterial mass exists, that new mass immediately begins contributing to further growth. This is the definition of exponential growth. The rate at which something grows is directly tied to how much of it is already there. Population. More animals means more babies. Radioactive decay. More unstable atoms means more radiation. Growth in reverse. Viral memes. More people sharing means more new people seeing it. Neural firing. The stronger the neural pathway, the faster it recruits new connections. Whenever you see a system where the speed is completely enslaved to the current amount, E is the shadow pulling the strings. E is the base unit of continuous, natural growth. To truly see the magic of E, we have to look at its function. Y equals e to the power of x. Let's draw the curve y equals 2 to the power of x. It starts low on the left, passes through 0, 1, and swoops upward. Let's analyze this curve. Imagine riding a roller coaster along it. We want to measure your steepness, or the derivative, at any given point. When your height on y equals 2 to the x is exactly 1, your steepness is about 0.69. When your height is 2, your steepness is 1.38. The slope is proportional to the height, but it doesn't quite equal the height. It's a bit too shallow. Let's warp the curve, steepening it into y equals 3 to the x. The car rides up. Now the slope is a bit too steep. When the height is 1, the steepness is 1.1. There is a Goldilocks zone. What if we warp the curve exactly between 2 and 3, until the altimeter and the speedometer read the exact same number? The curve elegantly shifts to perfectly rest at y equals e to the x. The car rides up. The altimeter and speedometer numbers spin wildly, but they are perfectly, permanently locked together. Height is 1, slope is 1. Height is e, slope is e. Height is 10, slope is 10. This is the magical property of e. The derivative of e to the power of x is exactly equal to e to the power of x. The height of the function is its rate of change. It is the only function in all of mathematics, aside from 0, that is exactly equal to its own derivative. If you ask a physicist or an engineer, I have a system where the rate of change is perfectly equal to its current state. What does it look like? They will instantly draw e to the x. The magic goes one layer deeper. Let's look at the area under this curve. The space under the curve, stretching all the way back to negative infinity, begins to fill with a bright glowing color, sweeping rightward until it hits an arbitrary point x. In calculus, taking the derivative, finding the slope, is the exact opposite of taking the integral, finding the area. Because e to the x is immune to the derivative, it is also immune to the integral. If you stop at the point where the height of the curve is exactly e squared, what is the steepness of the curve at that exact point? E squared. What is the total area of all the glowing space underneath the curve from that point all the way back to the beginning of time? Exactly e squared. At every single point on this curve, the value, the rate of change, and the accumulated history are all exactly the same number.